Good morning, everyone, and welcome to Q&I summer course. Hello, students. I am Sunit Kumar, your mathematics teacher. So, students, will start a new chapter today, that is polynomials. So, in the previous class, we completed the first chapter, that is number system. And today we'll start with polynomials, the second chapter. Okay, let's start the topic. So as I said, students, we'll start with a new chapter, that is polynomials. And today is the first lecture for this chapter. So first of all, we'll understand the basics of the chapter. So prerequisites for today's class is you should know about algebraic expressions. So this is one chapter which you have already done in class 7th and class 8th grade. And you should know about types of polynomials, right? And in today's class, students, we'll do polynomials in one variable, and we'll also learn about degree of a polynomial, what is the degree of a polynomial and how to find it out, the value of a polynomial, and what is zeros of a polynomial or roots of a polynomial. So this is what we are going to cover in today's class. So let's start. So let x be a variable. So you know what variable and what constant is, right? You have already done that in class 7th and class 8th when we started with algebra. So you know that variables are those numbers which are not fixed. So it is represented by alphabets like x, y, z, and it can take any value, right? The value is not fixed. And constants are numbers whose values are fixed. For example, 2, 3, 4. So these are the numbers whose values are fixed. So let x be a variable and n be a positive integer. And as a1, a2, an be constants, which are real numbers, then polynomial px can be represented as an x raised to the power n, an minus 1 x raised to the power n minus 1, and so on up to a1 x plus a naught. So this is called a polynomial in variable x, means single variable, right? Now, let us take one example. For example, polynomials are generally represented by small letters. So I am representing it by px. You can also represent it by fx. You can represent it by gx. So these are the name how you can represent a polynomial. Now, let's say the polynomial px is given as 4x square plus 2x plus 3. So here, what are the conditions here? You need to see that the, the coefficients, right? These are all constant. So 4 is a constant which is coefficient of x square. 2 is a constant which is coefficient of x, and 3 is a constant which is the constant term here, right? So these are different terms, 4x square, 2x and 3. These are called terms of a polynomial. So if there is one term of a polynomial, it will be a monomial. If there are two terms, we call it binomial. If there are three terms, it is called trinomial. So each of these, 4x squared, 2x and 3. So these are called the terms of a polynomial, right? Now, these terms in an algebraic expression or in a polynomial, they are separated by either a positive sign or a negative sign. So these are different terms, and every term will have, let's say, a variable and a constant. So if here in 4x square, the variable is x and its power is 2, and 4 is a number which is called coefficient. So this will be called coefficient of x square. So the number which is there along with that variable is called coefficient of that particular variable. So similarly in 2x, this is another term, and here 2 is called the coefficient of x. Is it clear? Now, what you also need to understand here is that the, the power of these variables, the power of the variable should be a positive integer. Then only we can call this algebraic expression a polynomial. So this is the this is the required criteria for an algebraic expression to be a polynomial. Okay, so for example, if we have something like this, px is equal to 2 times x raised to the power 1 by 2 plus 3x plus 4. Now here you can see, students, the power of x is 1 by 2, which is not an integer, it is a fraction. So when the power of x is 1 by 2 and it is a fraction and not an integer, it will not be a polynomial. So this is not a polynomial. Also, here, when I say positive integer, if we have another polynomial, gx is equal to 2 into x to the power minus 1 plus 3x plus 7. Here also you can see the power of x is negative. So this again will not be a polynomial because the power of x here is negative. So the power of the variable in a polynomial has to be a positive integer. It cannot be a fraction. It cannot be negative. So if the power of the variable in an algebraic expression is either a fraction or a negative integer, then that algebraic expression is not a polynomial. So for an algebraic expression to be a polynomial, the power of the variable has to be a positive integer. Is this point clear to everyone? Students, have you understood this concept? When an algebraic expression is called a
Yes, sir.
polynomial? Okay.
Mm.
So this is the general way in which we write a polynomial. So, a polynomial here
Sir,
is
can
written
you
as,
please repeat?
I'll repeat it. I'll repeat it. Just let me complete this and I'll repeat this again. So a polynomial px is represented as an x raised to the power n, where x is the variable and an is a constant. For example, in these examples, you can see 4x square. So 4 is the coefficient of x square. So an x raised to the power n, an is a constant. An minus 1 x raised to the power n minus 1. Here again an minus 1 is a constant. And similarly, it goes up to a1 x raised to the power 1 plus a0 x raised to the power 0. X raised to the power 0 is 1. So this a0 is a constant term, a1 is a constant term. All these coefficients are constant terms. Now let me explain it again to students who have joined late. So for example, if we have, so how to find an algebraic expression, whether it is a polynomial or not. So let us take few examples. Here, the first example is polynomial px is 4x square plus 2x plus 3. For an algebraic expression to be a polynomial, the power of x has to be a positive integer. So here the power of x is 2. Here the power of x is 1 and there is no term here. So this can be written as x to the power 0 because x to the power 0 is equal to 1. Right? So if you see here, the power of x in the polynomial here is positive integer in each of the terms. So that's why we will call this algebraic expression to be a polynomial. But let us take two more examples. This was your first example. Let us take this second example. Here the polynomial px is 2x raised to the power 1 by 2 plus 3x plus 4. Here the power of x is 1 by 2, which is a fraction and not a positive integer. That's why this is not a polynomial. Similarly, in another third example, gx, here the power of x is minus 1. So power of x minus 1 means it is not a positive integer. That's why again this algebraic expression is not a polynomial. So for an algebraic expression to be a polynomial, the power of x has to be a positive integer. It cannot be a fraction. It cannot be negative. Is this clear now?
Yes, sir. Yes. Yes, sir.
Okay. Someone who asked the question, is it clear to you? Okay. So let's move ahead, students. So in the polynomial px, an xn, So this one, this an xn, similarly an xn minus 1, a1x and a0, these are called the terms of the polynomial. So they are separated by either a positive sign or a negative sign between them. So these are called terms of a polynomial. Is everyone clear what are the terms of a polynomial?
Yes, sir.
Okay. And the constant which is written along with the variable in front of the variable. So this is an minus 1, a1, a0. These are called coefficients of terms, right? Different terms. So an would be the coefficient of, so this is coefficient of x to the power n. An minus 1 is coefficient of xn minus 1. A1 is coefficient of x to the power 1. So these are called coefficients. Is it clear? Okay, Anay, you want? Okay, I'll explain it. Anay. See, what we are saying here is we have, let's say we take 3 examples, right? I'll just rub this also. And one by one, let us understand. So let us understand the definition of polynomial. So a polynomial, an algebraic expression is called a polynomial if the degree or the power of the variable in that algebraic expression are all positive integers. That means whole numbers. For example, first polynomial px, as I said, was 4x square plus 2x plus 3. Here the coefficient of x square is 4, coefficient of x is 2 and 3 is the constant term. Power of x is 2, power of x is 1, right? Power of x is 1 in the second case, and in the third case there is no there is no term of x. So here you can see, so when there is no term of x, we can write it as x to the power 0. So the power of x is 2 here, power of x is 1 here, power of x is 0. These are all positive integers. That's why we say that this algebraic expression is a polynomial. In the second case, if you see, we had a polynomial 2x to the power 1 by 2, means it can be written as root x plus 3x plus 4. You can also write it as x to the power 1 by 2 plus 3x plus 4. Here, the first term, the power of x is 1 by 2, which is a fraction and it is not a positive integer. And that's why this is not a polynomial. Anna, is it clear for the second one? Yes, Arush, I'll explain the coefficients also. Now for the third one, if you see, so this was the second and this is your first. For the third one, if you see, students, we have another polynomial. I have represented it by gx. We can write any name, p, q, r, anything, right? So we have taken this as g. So g of x is 2 into x to the power minus 1, right? So this is 2 into x to the power minus 1 plus 3x plus 7. This can also be written as 2 by x plus 3x plus 7. If you see the power of x here, the power of x here is minus 1, power of x here is plus 1, and power of x here is 0. So here you can see minus 1, since it is not a positive integer, that's why. So minus 1, since it is not a positive integer, that's why we say that this polynomial, this algebraic expression is not a polynomial. Anna, is the third one also clear? Okay. So let's come to now, Arush has a question. Sir, can you explain coefficients again? I'll explain the coefficients again. If this is clear, can I rub this? Everyone? Rudra, Subhranshu, Hana, Arus. Yes, great. Okay. Now let us understand the coefficients of a polynomial. So we'll take few examples, and then in each example, we'll see the coefficient of all the terms. So let's say first example, Px is 4x square plus 3x plus 7, right? Now in this polynomial, we have three terms. First term is 4x square, second term is 3x, and the third term is 7. Now in this term 4x square, coefficient of x square means what is the constant which is multiplied to x square to get that term. So constant which is multiplied to x square to get that term is 4. Other than x square, what other things are there? What other numbers are there in this term? For 4 is that another number, right? Which when multiplied to x square gives us the term 4x square. So 4 is the coefficient of x square. Now here in 3x, coefficient of x is going to be equal to 3, because other than this, the x, we have one number multiplied to it, that is 3. So 3 will be the coefficient of x. Similarly, here 7 is a constant term, right? So if someone would have asked what is the coefficient of x to the power 0, in that case, coefficient of x to the power 0, I can write it as 7. Or 7 can also be written separately as a constant term. Now, is the coefficient clear to everyone what coefficient means? So we have seen three things. Which algebraic expressions are polynomials? We got to know that. Second, we got to know what are the terms of a polynomial. Third, we got to know what are the coefficients of each term of a polynomial. Is it clear? Anay, Arush, is it clear to everyone? Okay.
Yes, sir.
Okay, let's go to the next now. So you can see the expression, algebraic expression 2x square minus 3 root x plus 5 is not a polynomial. Why is 2x square minus 3x plus 5 minus 3 root x plus 5 not a polynomial? Who is going to tell me? Why is this not a polynomial?
Sir, because the x to the power is in root.
Yeah, so here, yes, Anay, you also wanted to answer. Why is it not a polynomial, please? Okay, so here, if you see the polynomial px as this is 2x square minus 3 root x plus 5. So here you can see power of x is 2. Power of x, because it is root x, power of x will be 1 by 2. And here power of x is 0. So since the power of x here is fraction and not a positive integer, that's why this is not a polynomial. Is it clear? So 2x square minus 3 root x can be written as x to the power 1 by 2 plus 5. Now, expression like this also is not a polynomial. Why is this not a polynomial? The second example, px is equal to 1 by x square minus 2x plus 5. Why is it not a polynomial? Can someone tell me? Yes, Anay.
सर क्योंकि उसकी पावर नेगेटिव में थी इसलिए उसको
Yes.
1 अपॉन करके लिखा गया.
So when I write 1 by x square, so when you take simply, if it would had been 1 by x square, if you take x to the numerator, it would had been x to the power minus 2. 1 by x square could have been written x to the power minus 2. So the power of x here becomes negative. Clear? So whenever you have a variable in denominator, right, and there is nothing in the numerator, means you cannot cancel out the variable in the denominator with some variable in the numerator, then in that case, this is not a polynomial. I'll give you another example. And you have to tell me whether it is a polynomial or not, right? Shall I rub this?
Yes, sir.
So understanding the basic concept is very important. So Px polynomial, if we have something like x square plus 3x plus 2 divided by x plus 2. Can you tell me whether it is a polynomial or not? And you have to give me the reason also why it is a polynomial or why it is not.
Sir, it will be not the polynomial because in the denominator x to the power 1. So if they will upper in that we will it's x to the power minus 1.
Any other answer? Thanks for answering, Arush. Anyone else who wants to counter Arush that this no, this is not correct? No one. So Arush is correct. Let us assume. Shall we assume that Arush is correct? Okay, Anay is saying yes. Great. So I'll tell you. We can factorize this numerator as x plus, so x square plus 2x plus x plus 2. If we middle term split this, you know how to split the middle term, right? Factorization by splitting the middle term. So you break 3x into two parts, that is 2x and x, so that the sum is 3x and the product is 2. So 2 into 1 will give you product 2. Divided by x plus 2. So this can be written as take x as common, we'll have x plus 2. 1 as common, we'll have x plus 2, and this is x plus 2. Now this is x plus 1 into x plus 2 over x plus 2. Correct? Now you can cancel this x plus 2. You are going to get x plus 1. Now on simplifying, do we have any term in the denominator now?
No, sir.
So now tell me whether it is a polynomial or not.
Yes, sir.
It is a polynomial, right?
Sir.
So what you also will need to check that, looking at the question alone, we cannot directly say whether it is a polynomial or not. Try to simplify it. If there are some like terms, if there are some common terms which can be cancelled from the numerator and denominator, then in that case, you have to cancel it and then check whether it is a polynomial.
Okay, sir.
Okay. Anay, Laksh, Saranya, everyone, is it clear to everyone? Arsh, is it clear to you as well? Subhranshu? Okay. So now we have understood this. I suppose we have understood this, right? Let's go ahead. Now let us understand what is the degree of a polynomial. Who is going to tell me what is the degree of a polynomial?
Sir, can I?
Yes, yes.
So the highest power of a variable in the whole polynomial.
Yeah, so highest power of the variable in the polynomial, given polynomial, will be called the degree of the polynomial. So if you see the definition, exponent of the highest degree term in a polynomial is known as its degree. The highest power of x in polynomial Px is called the degree of polynomial. If the polynomial is with variable x, then highest power of x. If the polynomial is of variable y, then highest power of y. So currently in grade 9, we will be considering only polynomials with one variable when we are calculating the degree. So that's why if there is something like this, so polynomial px is x to the power 4 plus x to the power 8 plus 7. So highest power, see here the power of x is 4, here the power of x is 8, and here the power of x is 0. So highest power is 8. So we will say that degree of this polynomial is 8. Now, specifically, right now we are only focusing on polynomials with variable, one variable. We will not take something like this y to the power 8 plus x4 y5 plus y to the power plus x to the power 2 plus 7. We will not consider this right now. Okay. When you have to find the degree of a polynomial, it has to be specifically the polynomial with one variable and not more than one variable. Okay. So the highest power of x in a polynomial px is called the degree of the polynomial. For example, in this polynomial gy, 2y square minus 3 by 2y plus 7 is a polynomial of degree 2, because here the power of y is 2, here the power of y is 1, here power of y is 0, right? So that's why the highest power is 2, and that's why we call the degree of the polynomial is 2. Is it clear to everyone? Has everyone understood the degree of a polynomial?
Yes, sir. Yes.
Okay. So if you want to note this down, please note this down. Okay. Let's go to the next now. Now, constant polynomial. What is a constant polynomial? So constant polynomial is that polynomial where you don't have a term with any variable. So if a polynomial has no term which has a variable in that, is called a constant polynomial, right? For example, so polynomial of degree 0 is called a constant polynomial. So for example, we have polynomial px is equal to 5. So this means 5 into x to the power 0. So the degree of this polynomial is 0. So that's why this polynomial px is equal to 5 is called a constant polynomial. Correct? So for example, px is equal to 7 is a constant polynomial. Okay. So the constant polynomial px is equal to 0 is called a zero polynomial. So specifically, if that constant polynomial is equal to 0, means if we have a polynomial px equal to 0, that constant which we are talking about now is 0. So then in that case, this constant polynomial will be called a zero polynomial. Now, when I say the degree of a constant polynomial, so degree of constant polynomial, this is equal to 0. What will be the degree of zero polynomial? What is the degree of a zero polynomial? Can someone tell me?
Sir, it will be 0.
Okay. Anyone else? Anna is also saying 0. Hana is also saying 0. Okay. Let me again ask some questions with you. So px is equal to 0. Now 0 can be written as 0 into x to the power 0. This can also be written as 0 into x to the power 1, or 0 into x to the power 2, or in fact 0 into x to the power n, because 0 multiplied with any power of x will be equal to 0 only. Now, if I consider this, the degree will be 0 as you are saying. If I consider this, degree will be 1. If I consider this, degree is 2, and here the degree is n. So can we define the degree of a zero polynomial?
Not defined, sir.
Yes. So degree of a zero polynomial is not defined. Very good. So degree of a constant polynomial is zero. That is fine. But degree of a zero polynomial is not defined because zero polynomial can have any power of x. Because 0 multiplied by any power of x is going to give you 0 only, that is 0 polynomial. So because the power of x is not defined, the degree is also not defined for a 0 polynomial. Is it clear? Okay, Anay and Rudra is saying no, it is not clear. I'll I'll try and explain you again.
Sir, they are actually they are clear, sir. That is the old messages.
Okay, okay. So Anay, it is clear. Rudra, it is clear. Yeah, good, 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 good. So we'll repeat it once. Degree of a constant polynomial is 0 and degree of a zero polynomial is not defined. This is very, this is important because this is being asked in every MCQ, every test which you will take in school, or this is a tricky question. What is the degree of a zero polynomial? So generally people tend to make mistake by answering it as 0, but it is not defined. So you have to answer accordingly in the MCQ kind of questions or assertion reasoning, or questions which are being asked in these Olympiads. You will find these tricky questions a lot. Okay, shall we move ahead? Okay. So degree of a zero polynomial is not defined and degree of a constant polynomial is 0. Now linear polynomial. So before going into linear polynomial, I'll just quickly you know discuss what are the different types of polynomial in terms of number of terms, right? So types of polynomial in terms of number of terms, right? So if there is one term, in that case, so if there is one term, in that case, that polynomial is called monomial. So monomial has one term. Example of monomial would be polynomial px is equal to, let's say, 5x square. There is only one term here. Similarly, polynomial gx is equal to 7x cube. Again, here we have only one term. So such polynomials having only one term are called monomials. Then when you have two terms, a polynomial having two terms is called binomial, right? Example of binomial would be, let's say, polynomial px is equal to 5x square plus 7x. So there are two terms here, and that's why this is a binomial. Similarly, gx is equal to x plus 7. Again, we have two terms here, and that's why this is called a binomial. Now, if you have three terms in a polynomial, this is called trinomial, right? So example would be 5x square plus 7x plus 7. So this is a trinomial because there are three terms here, right? And in general, all these are called polynomials. So specifically, those polynomials having one term is called monomial. Those polynomial having two terms are called binomial, and those polynomials having three terms are called trinomials. And in general, all of this is called a polynomial. Is it clear?
Yes, sir.
Okay. Now I'll quickly rub this. Has everyone written this? Now let us consider the types of polynomials, which is differentiated by the degree of the polynomial. So a polynomial having degree 1 is called a linear polynomial. Okay. So now we are considering types of polynomial. Types of polynomial on the basis of degree of a polynomial. Okay. So a polynomial of degree 1 is called a linear polynomial. Example would be x plus 7. Here the degree is 1 and that's why it is called a linear polynomial. So in general, a linear polynomial can be written as ax plus b, where x is the variable and a and b are constant. So this is the general form of linear polynomial. So this is general form of linear polynomial. Is it correct? Is it clear to everyone? Okay. So example is, px is equal to 4x minus 3. So this is the example. And the general form of linear polynomial is ax plus b. Px is equal to ax plus b, where a is not equal to 0 and a and b are real numbers. Why is a not equal to 0? Can someone tell me? Why is this statement written that a is not equal to 0? What will happen if a is 0? Yes,
Sir,
Anu.
if A is 0, that whole equation will be 0.
No, not the whole equation, but that term will become 0. For example, if a is 0, the polynomial px ax plus b would be written as 0 times x plus b, right? Which is equal to 0 plus b or only b. Now here, this polynomial becomes a constant polynomial and not a linear polynomial, right?
Yes, sir.
So that's why a cannot be 0. If a is 0, that means it is not a linear polynomial. It will become a constant polynomial. Clear? That's why we specifically say that a is not equal to 0. Okay. Now the quadratic polynomial. What are quadratic polynomials? A polynomial with degree 2 is called a quadratic polynomial, right? So polynomial of degree 2 is called a quadratic polynomial, correct? So example of a quadratic polynomial would be 2x square plus 3x minus 4 by 5. So here you can see the degree is 2, right? Degree is 2 and that's why this is a quadratic polynomial. General form of a quadratic polynomial would be ax square plus bx plus c. So polynomial px equal to ax square plus bx plus c, where a is not equal to 0 and a, b, c are real numbers. So if a is equal to 0, then again the same thing, this will become 0 and the degree will not be 2. So because if the degree is not 2, then it will not be a quadratic polynomial. And that's why a cannot be 0. The coefficient of x square shall not be 0. Rest other terms can be 0. For example, we can have something like this. Px is equal to 2x square plus 5. So here we don't have any term of x, but still it is a quadratic polynomial because the degree here is 2. Is it clear? Anna, you want to ask something? Okay. Now a cubic polynomial. So a cubic polynomial, the name itself suggests that if the degree of the polynomial is 3, then such a polynomial is called a cubic polynomial, right? So a polynomial of degree 3 is called a cubic polynomial. Okay. Example of a cubic polynomial is 4x cube minus 3x square plus 2x minus 1 by 3. So this is your cubic polynomial. So here the degree here is 3. Degree of this polynomial is 3. Okay, so that's why this is a cubic polynomial. The general form of a cubic polynomial, so general form of the cubic polynomial is ax cube plus bx square plus cx plus d, where a not equal to 0, because if a is 0, then x cube, the term with x cube will become 0 and it will no longer remain a cubic polynomial. That's why a should not be equal to 0, and a, b, c and d are real numbers. Clear? Okay. Now we have a biquadratic polynomial. Biquadratic means, bi means 2. 2 times quadratic, that means degree 4. So a polynomial with degree 4 is called a biquadratic polynomial. Example is polynomial px is equal to 3x4 plus 2x cube plus 4x square minus 7x minus 1. Here the degree is 4, and that's why this is called a biquadratic polynomial. General form of a biquadratic polynomial would be px is ax4 plus bx cube plus cx square plus dx plus e, where a is not equal to 0 and a, b, c, d and e are real numbers. Is it clear? Quickly note this down. Let's move to the next now. Now, if you see here, students, in this example, you have to find the degree of each of the polynomial given below. So if you see this x5 minus x4 plus 3, what is the degree here, students? Yes, Anay, I will explain the third again. Third one as in the biquadratic or cubic one? Biquadratic. Okay. So a polynomial of degree 4 is called biquadratic. Biquadratic means, bi means 2. 2 times quadratic. So if you take a square of quadratic degree 2, that will become degree 4. So polynomial of degree 4 is called biquadratic. And here the degree is equal to 4, that is 3x4 plus 2x cube plus 4x square minus 7x minus 1. In this example, the degree is 4. Now, since the degree of 4, degree is 4, this is called a biquadratic polynomial. And in general, a biquadratic polynomial is written as ax4 plus bx cube plus cx square plus dx plus e. So here the degree is 4. A, B, C, D, E are real numbers and a is not equal to 0. Okay. Now, degree of each of the following polynomials. So here, what is the degree of this polynomial, students?
5.
5. Correct. So degree here is the highest power of x, which is 5. So degree is 5 here. In the second one, what is the degree?
8.
Yes, Rudra and everyone. Correct. So degree here is 8. What is the degree here?
1.
0.
1.
Degree is 0. Degree is 0.
It is not
Because
the value.
2 times x raised to the power 0, right? So degree is 0 here. Constant polynomial, the degree is 0. 0 polynomial, degree is not defined. Okay. Now, which of the following expressions are polynomials in one variable and which are not? So you have to tell me which are polynomials of, polynomials in one variable and which are not. You have to note that you have to also find that it should be of one variable. First one, is it a polynomial?
Yes, sir.
Yes, sir.
Yes, it is a polynomial because you see that the power of all the variable is a positive integer or non-negative integer. Okay, so non-negative integer means these are all whole numbers, right? So this is a polynomial. What about second one? Is it a polynomial?
It is not.
No,
It
sir.
is not a polynomial.
It is a polynomial because, see, we have to see the power of variable here. Power of variable here is integer, positive integer.
Yes, it is
Here,
polynomial.
here it can be written as y to the power 0. Now this again is not negative, right? So the power here are whole numbers, and that's why this is a polynomial. Don't see root 2. Root 2 is the coefficient. The root should not be over the variable. Here the root is on a number which is a constant. So this is a polynomial. What about the third one?
It is not
It is not,
polynomial.
because here the power of t is fraction 1 by 2. Right? This can be written as 3t raised to the power 1 by 2 plus t root 2, t to the power 1. So here, because the power is a fraction, this is not a polynomial. What about the fourth one?
Sir, the fourth one is the not is it is not the polynomial because the y to the power will be -1.
Yeah, because in the second term, y is in the denominator, and when you take it to numerator, you will write it as y plus 2y minus 1. So this is not a polynomial because the power of y here is negative. Correct? What about fifth one? Is
Sir,
it a
it is not
polynomial?
a polynomial.
Sir,
It
it
is
is
not
not the polynomial
because here
is
are
the
three variables.
linear equation
Yeah,
in three variables.
yeah, it is a polynomial, but it is not a polynomial of one variable. It is a polynomial of three variable. So when the question would have been ki you have to find whether it is a polynomial or not, so yes, it is a polynomial. Now if they ask you whether it is a polynomial of one variable, then you will say no, it is not a polynomial of one variable. It has three variable. Correct? So I'll write it as not a polynomial in one variable. It is a polynomial, but in three variable. We had to find whether it is a polynomial in one variable. Correct? Let's go to the next one now. You have to write the coefficient of x square in each of the following. What is the coefficient of x square here? In the first one?
Sir, 1.
Yes. Coefficient of x square means what is multiplied with x square. So here 1 is multiplied with x square. So coefficient of x square here is 1. What is the coefficient of x square in the second
1
polynomial?
-1.
minus
Yeah.
1.
Yes, Rudra, correct. So here the coefficient here is, because you can write it as 2 plus -1 into x square plus of x cube. So coefficient of x square here is -1. What is the coefficient in the third example?
Pi upon 2.
Pi upon 2. Pi upon 2.
Pi upon 2 is the coefficient here for x square. And for the fourth one,
Under root 2.
coefficient of
Root
x.
2.
No,
Root 2.
sir, no
We-
one. No one. Nothing.
0.
Sorry.
See, I can write this as 0 into x square plus root 2 into x minus 1. So coefficient of x square here is 0. Right? Why? Because there is no term of x square. So since there are no terms of x square, that means coefficient of x square is 0. Clear? Yes, Rudra, you are correct. So if in this case it was root 2 x square, then coefficient of x square would have been root 2. Shall we go ahead?
Yes, sir.
Now you have to give one example of a binomial of degree 35. Can you give one example of a binomial of degree 35? Anything, 7x 35 plus x plus 1. This is, sorry, this you have to find only binomial. So this is the binomial with degree 35. You can take any example. Yes, you had to write a binomial, Rudra. Now, second one is monomial of degree 100. So monomial of degree 100 is 4x raised to the power 100. This is a monomial because it has only one term and the degree is 100. Yes, Rudra, it is correct. Is it clear to everyone? Binomial of degree 35 and monomial of degree 100. You can take any example. Yes, Anay, you can take that as well. 5y 35 plus y to the power 35. Yes, 2x to the power 100. This can also be taken. Now, you have to tell me the degree of each of the following polynomial. What is the degree here?
Sir, 3.
3.
Degree is 3. In the second one?
2.
2.
Yes, the degree is 2 because the power of y maximum is 2. Third one?
1.
And fourth one?
Iska 0.
0.
0. Good. I hope everyone is noting down. Those who are not answering, please keep on noting it down.
Sir,
if
we
you
have to also write the questions.
No, don't write the question because these are there in your NCERT, the questions which we are doing today. This is the basic introductory class, right? Now you have to classify the following as linear, quadratic, and cubic polynomial. What is this first one?
Quadratic.
What polynomial? It is a quadratic polynomial because the degree is 2. Second one?
Cubic.
Linear and cubic.
Cubic because the degree is 3. Again? Quadratic because the degree is 2.
Linear.
This is linear because degree is 1. Linear because degree is 1. Quadratic because the degree is 2.
Cubic.
And this is cubic because the degree is 3. Okay?